Welcome to qnawire.
In this question, we are given that an elevator is moving upward. Inside the elevator, we have a weighing machine on which a person is standing. The elevator is moving upward in such a way that for a while the elevator is speeding up with a constant acceleration, and then for a certain amount of time the elevator is moving up with a constant speed, and then before stopping the elevator is decelerating. It is mentioned that the magnitude of acceleration and the magnitude of deceleration of the elevator are same. It is also given that the maximum weight as measured by the weighing machine is 72 kg. Actually, it is the maximum mass as measured by the weighing machine, and the minimum mass as measured by the weighing machine is 60 kg. So we have to find what is the magnitude of acceleration of the lift or of the elevator, and also we have to find what is the true weight, or actually what is the true mass of the person. So to answer this problem, let's try to understand how an weighing machine measures weight. Suppose this is a weighing machine over which a person is standing. Let's say the mass of the person is m, that is the actual mass. Then the weight of the person will be acting downward, that is mg, and the weighing machine will give a normal reaction force on the person that will be acting in the upward direction. Okay, and at equilibrium this normal reaction force will be equal to mg. So what weighing machine will do? Weighing machine will first measure the value of n. So we can just say one thing, that weight measured by an weighing machine is equal to normal reaction force on the person. Okay, so we can just write that n is equal to mg. Then the mass measured by the weighing machine, mass measured will be normal reaction force by g, that will be the mass as measured by the weighing machine. Whenever the elevator moves upward with acceleration, in that case the normal reaction force on the person will be changing. Even when the elevator moves downward, in that case also the normal reaction force on the person will change. So let's try to calculate when the elevator moves upward. Elevator moving upward with an acceleration a. So acceleration of the weighing machine is a. Now let's say the actual mass of the man is m. Then on the person, what are the forces that will be acting with respect to elevator's reference frame? First of all, it's the mass of the weight of the weight will be acting downward. On the person, a normal reaction force will be acting upward, and since the elevator is moving upward with an acceleration a, so on the person also a pseudo force will be acting downward. So the net force that will be acting downward is mg plus ma, and with respect to elevator's reference frame, we can say the net normal reaction force has to be balanced by mg plus ma. In this case, this n prime is the weight as measured by machine, right? So we can just write n prime equal to m into g plus a. Let's say this is your equation number 1. Actually yeah, this is, let's say, equation number 1. And remember, whenever the elevator moves upward, in that case the weight measured by the uh, weighing machine will be maximum, so the mass of the person will be maximum. So I can say the maximum mass of the person, the maximum mass of the person, let's, that is m max, that will be basically this normal reaction force divided by g. So if you do that, you will get m into g plus a by g, so which you can again simplify, and you can write the maximum mass as measured will be m plus m into a by g. This is, let's say, my equation number 2, which is very, very important. Okay, when the elevator moves upward with a deceleration, so in this case we will denote the deceleration of the elevator as minus a. So in that case, on the person, the pseudo force will be acting in the same direction of the direction of motion as the elevator is having deceleration. So now if I just want to know what are the forces acting on the person, so as usual, its actual weight mg will be acting downward, and the normal reaction force on the person will be acting upward, let's say that is n double prime. In addition to that, a pseudo force will be acting, that will be in the upward direction, that is m into a. Okay, so this is the case when the elevator is moving up with constant deceleration a. Okay, so in this case, again, with respect to the reference frame of the elevator, I can write that n double prime plus m into a has to be balanced by mg, or we can write the net normal reaction force will be m into g minus a. Okay, so if I name this equation as, let's say, equation number 3, then as we know that the normal reaction force is nothing but the weight as measured by the weighing machine. So in this case, as the elevator is having the deceleration, so the weight measured will be minimum, as you can see it is g minus a. So in that case, the mass measured by the weighing machine will also be minimum. So I can write the mass measured in this case, let's say that is m minimum. As I said, it will be minimum mass, that will be how much, that will be n double prime by g. So on simplifying this, we will get m minus m into a by g. So this is my fourth equation. We are given that the value of maximum mass as 72 kg and the value of minimum mass as 60 kg. Then from 2 and 4, by adding, I will write by adding, what we will get if we add the two equations, second and fourth, we will get m max plus m min equals 2m, or from here I will get the actual mass of the person as m max plus m min divided by 2. Okay, so if we put the values, we will get m as 72 plus 60 by 2, that will be 66 kg. So this is the answer for part A. This you can write a part A answer. Part A answer. Now in part B we have to find the acceleration, the magnitude of the elevator. So how we can do that? We can add equation 2 and 4. Sorry, we can subtract equation 2 and 4. So by subtracting equation 4 from 2, we get maximum mass minus minimum mass as equals to 2m into g by a. So from here I can write that the acceleration magnitude of the elevator will be 2 mg by m max minus m min. Okay, so now we can put the data what we have got. A will be equal to 2 times m, we got 66 kg. G we can take, G we have to take 9.9 divided by m max is 72 minus m min is 60. So on simplifying this we will get A equals 0.9 meter per second square. So this is the answer for part B.